So good morning everyone and welcome to this lecture. This is lecture number 5 and we are dealing with Ohm's law. If you remember, what did we do in the last class? Anyone remembers it? Hmm? Anyone remembers what we had done in the last class?
Yes, sir.
What did we do in the last class? Tell me.
Ohm's law, resistance,
Good. We were dealing with Ohm's law.
dependence of resistance.
Great. Everyone remembers it. Good. You are getting better. We did this formula V is equal to IR, where R is the resistance of the conductor, I is the current, and V is the voltage drop. Everyone remembers it.
Yes, sir.
We have seen this graph of V versus I. Remember, Ohm's law is not a universal law. The conductors or bodies or materials which obey Ohm's law are known as ohmic conductors or ohmic materials. But there are non-ohmic bodies as well. Bodies, materials, we do not obey Ohm's law, and you must remember them because this might come as a question in your exam. Then we had seen what do you mean by resistance. Resistance is the slope of VI graph. V by I is resistance, and sometimes the graph is given between I and V. When the graph is between I and V, the slope of that graph gives us conductance, and conductance is the reverse of resistance. Now, if conductance is the reverse of resistance, we had seen that the SI unit of resistance was ohm. What will be the SI unit of conductance? Yes, that's the first question. What would be the SI unit of conductance?
More.
Okay, so that means you are prepared. It is ohm raised to the power of -1. Now, instead of writing it as ohm raised to the power -1 or 1 by ohm, we also write it as the inverse of ohm, which is mho. Ohm, inverse of ohm, which is mho, and the dimension becomes the reverse of the dimension of resistance. So the dimension of this will become m minus 1, L minus 2, T cube, and A squared. So that will become the dimensions of this mho or conductance. Now, this is the most important aspect of this chapter is this Ohm's law, because rest of the things that Kirchhoff's law and everything we have already covered in the chapter on capacitance. Even series and parallel we have covered in capacitance. Will come again, but we have already covered it. This is the part that we have not covered in capacitance, and this is the part from where most of the questions for NEET are going to come. Relation between resistance and this, resistance and conductance, this graph, that graph. So you must be very careful about this, and also remember the units and dimensions of resistance because they come in exams many times. Then what we had seen next, what we had seen the dependence of resistance, and we had devised the formula. We had found out a formula. Resistance is rho L by A. Do we remember this formula? Resistance is rho L by A,
Yes, sir.
where rho, the new term, is known as the resistivity of a conductor. And on what all factor the resistivity of a conductor depends on? I told you that it depends on the material of the conductor and its temperature. Yes or no?
Yes, sir.
We had also seen this revolutionary graph, and this is one of the most important graphs in this chapter, where you have seen how resistance varies with temperature. It is almost a straight line. R naught is the resistance at 0 degrees Celsius, and RT is the resistance at any given temperatures, and alpha, this alpha is known as temperature coefficient of resistance. We had covered the majority of this resistance in the previous class, but we'll go ahead with more things that we might have to understand about this. Do we understand this?
Yes,
Up
sir.
till here, it is clear to everyone. Boys, I am not hearing anything from your side. Are we there or we have gone?
Sir, yes, sir.
What, sir? You are there, na, sir?
Yes, sir. There, sir.
Or we have gone and started chilling out outside. Okay, so these are the factors on which resistance depends on. Very important formulae we have seen. Now, this is the formula of how resistance of a conductor varies with temperature. Now remember, as you can see, I have written here in this pink thing, resistance is directly proportional to temperature. If the temperature of a conductor increases, the resistance increases. What will happen if you decrease the temperature? What will happen if you decrease the temperature of a conductor? Huh? What will happen if you decrease the temperature of the conductor? Tell me. What will happen if you decrease the temperature of the conductor? Huh? What will happen if you decrease the temperature of the conductor?
Resistance decreases.
Yes, if the temperature of the conductor is decreased, this sign means decrease. The resistance of the conductor also decreases. So resistance is directly proportional to the temperature of the conductor. If the temperature of the conductor increases, it increases. If it decreases, the resistance decreases. Then we can understand that at some point in time, the resistance of this conductor may become zero. Theoretically it happens, it may not happen actually. No one can have zero resistance, but at some temperature the resistance of the body can literally become zero. That temperature is known as the critical temperature. That temperature where the resistance of a conductor becomes zero is known as the critical temperature, and at this temperature the conductor becomes a superconductor. You might have heard about these terms, superconductor materials. This is a superconductor. Basically, when we say a body is a superconductor, we basically means the resistance of that body is literally zero, very close to zero. It does not offer any resistance, and therefore it becomes a superconductor. Everyone understands this, yes or no? I'll give you 1 minute
Yes,
to
sir.
note it down fast. So I think you have noted it down. At a critical temperature, the temperature at which the conductor becomes a superconductor. Now, there are very there are a few questions that I have seen which is based on this concept. What happens when temperature increases? Will the resistance increase? Will the resistance decrease? So it depends on what material are we talking about. So we will see some important points about these. When will resistance increase and when will resistance decrease? The simplest example is for a metal. For a metal, metals are conductors. Metals are conductors. So for a conductor, if you increase the temperature, what will happen? Will the resistance increase or will the resistance decrease? Huh? For a conductor, will the resistance increase or resistance decrease when the temperature is increased?
Increase.
Resistance increase, sir.
Resistance increase. So that is the first point that you must remember, bacha, that for metals, when temperature alpha is greater than zero, alpha greater than zero means when temperature increases, resistance increases. But again, this is not universal. Again, it is not universal. For all metals, for all, sorry, not for all metals, for all bodies, the resistance may not change. It may also decrease. So for metals, my dear friends, the resistance always increases. But But point number two, for solid non-metals, alpha is 0. Resistance is independent of temperature. So for non-metals, solid non-metals we are talking about, resistance does not depend on temperature. A very important point on which very a lot of questions have come. Different metals, different materials. What happens when you change the temperature? I hope everyone is noting them down. Yes or no? No, yes.
Yes, sir.
The third one are semiconductors. We will deal with this semiconductors in modern physics. Semiconductors, their conductivity lies between conductors and insulators. We have already seen that. For semiconductors, the blue ones, alpha is less than 0. That means as you keep on increasing the temperature, resistance of the semiconductor actually decreases. A very important thing that you must remember for semiconductors, alpha, the temperature coefficient of resistance is negative. That means the resistance will decrease. Similar is the case with an electrolyte. Electrolyte, your favorite topic, chemistry, subject chemistry, electrolyte. Also, alpha is less than 0. You must remember these things for which alpha is less than 0. You can club them together. Semiconductors, electrolyte, alpha is less than 0. At the same time, you might have these alloys. We use a lot of alloys. Sorry, ionized gases is the next one. Alloys is the next one. For ionized gases, also this alpha, for ionized gases, also this alpha is less than 0. So you can put them in the same category of semiconductors. Decrease. Their conductivity decrease with increase in temperature. I hope everyone is noting it down. Do we understand this? Yes or no? I'll give you more time to write. Don't worry about that. Now comes the next point, and next point are alloys. Now for these alloys, and you will see that for alloys, if you're talking about alloys, for alloys, what happens is they have alpha, which is positive, but it is a very small value, and therefore it almost remains constant. For alloys, has very small positive values, so the resistance will almost remain constant for alloys. And lastly, we have our new bodies that we have found out. Those are superconductors. For superconductors at low temperature, their conductivity becomes infinite, their resistance becomes exactly 0. So remember all these different types of bodies. What happens when you increase the temperature for all these bodies? For some bodies, the with change in temperature, resistance increases. For some bodies, it remains same. For some bodies, it decreases. And for superconductors at low temperatures, the resistance is almost 0. I'll give you 2 minutes to note this down. Note this down and let me know. Okay, since you have done, let us move ahead. Now, many a times you are going to get questions where you might be asked to find out what is the resistance when potential difference is applied in different ways. Now remember, we have seen the formula of resistance in terms of resistivity. What was the formula of resistance in terms of resistivity? It was rho L by A. Do we understand this? Do we remember this? The formula of resistance was rho L by A. We remember this? Yes or no? Do you remember this formula of resistance, rho L by A?
Yes, sir.
Now, depending on how I am applying the potential, there could be different values of L and A for even the same conductors. Now, please don't get confused, and I will try to explain. Let us say I will take this case and let me call this as case number 1. Let me call this as case number 1. You can see this case number 1 on your screens. Now, what I have done here, and if I have to show you, this is what it helps. This is a rectangular or a cubical, not a cubical, cuboidal conductor I have. Now, I can connect this conductor to a battery in different ways. What I have done in the first case, I have connected this face, the upper face. You can see the upper face. I have connected this upper face and the lower face to a battery. Do we understand this? The upper face and the lower face. We understand this? Yes or no? Do we understand?
Yes, sir.
I have connected the upper face and the lower face to a battery, and this is how it looks. This this is the upper face, and I have connected it to a battery, and the lower face is upper and the lower face is connected to the battery. Now the resistance, the resistivity of this conductor, as you can see, is rho, and since it is a cuboid, it has got length, breadth and height. This is given as A, you can call it as length. This is given as B, you can call it the height, A, B, and this is given as C, you can call it the depth. Do we understand this? A, B, and C. Do we understand this?
Yes, sir.
Now, depending on how I have connected this conductor, can you tell me what will be the resistance of this conductor? Because depending on how I have connected this conductor, the area and the distance, length of the conductor varies. In this case, can you tell me what would be the resistance of this conductor in terms of the given quantities? What are the given quantities? The given quantities are rho, B, A, and C. What will be the resistance of this conductor in terms of these quantities? Yes. What would be the area of this conductor and what will be the length of this conductor? Remember, I have connected it in this way. I have connected the upper face and the lower face to the battery. Can you now tell me what would be the resistance of this conductor? Can you tell me? Anyone? The conductor is like this. I have connected this upper face and this lower face. So I have to find out the area of this face. What is the area of this face? What is the area of this face? This is A, this is A, and this is C. Do we remember? This is A and this is C. So what will be the area? What will be the area? This is A. And this is C. What will be the area of this conductor? Area of this conductor is the area of this portion. What is the area of this portion? No one knows it. The area of this portion is length, whatever length and the breadth. So area of this portion will be how much? No one knows it. Okay. Area of this portion will be A multiplied by C. Now I think about what is the length of this conductor. Current is going from top and current is coming out from the bottom. So this is the length of the conductor. This is the length of the conductor. When I talk about this length, I'm basically talking about the height B. So the length of this conductor would be B, and therefore the resistance of this conductor. Can you now tell me what is the resistance of this conductor when it is connected in this fashion? Can you tell me what is the resistance of this conductor now? I've told you everything. Can you now put the formula and tell me what will be the resistance of this conductor?
Rho B by AC.
Resistance of this conductor will be rho B by AC. Well done. And this is how we can find out the resistance of conductor if it is connected across different ends. Do we understand this? Yes or no? Do we understand this? Yes or no? Do we understand this? Yes or no? I'm asking you something. Do we understand this, beta?
Yes, sir.
Okay, I'll give you 2 minutes to note this down. Let me know once you are done. So I hope you have completed it. Now comes this case, case number 2. Now I have connected the same conductor, not from top to bottom, from this side, this side, this side to this side. It's connected like this, from this side to this side. As you can see, this is the area of the conductor now, because it is connected like this. Can you tell me how much is this area? Because this is connected across this. This is the area now, the side one. This is the area now. Can you tell me what is this area equal to? Can anyone tell me what is this area? This side is C and this side is B. Can you tell me what is the area? What is the area of this conductor, beta?
BC.
Area of this conductor is BC. Oh, why I'm writing B by C? Area of this conductor is BC. Can you now tell me what will be the length of this conductor? This is the
A.
length of this conductor. What is the length? Length of this conductor would be A. Can you now tell me what would be the resistance of this conductor?
Rho A by BC.
Rho A by BC. Remember, this is the same conductor that we have taken. The only thing that we have changed is simply the connections we have changed, and because of the change in the connection, the resistance has changed. Why the resistance has changed? Because the area of the conductor is different now, and the length of the conductor is different now. We understand this, everyone? Yes or no? No, yes.
Yes, sir.
I'll give you 2 minutes to note this down. Okay, then, since we are done, we move on to the third case, and the third case is like this. The first case was we connected upper and lower half. The second case was we had connected this side and this side. The third case is we are going to connect this face, this side, and this side. This face and the back face. Now again, let us think about the area. Can anyone tell me what is the area of cross section now? Yes, bacha. This I have painted for you. I am not good at painting, but I have tried. What is the area of the cross section here?
AB, sir.
Area in this case is AB. What about the length of this conductor? As you can see, this will be
C.
the length of this conductor, and the length of this conductor L will be equal to C. Can you now tell me what will be the resistance of this conductor?
Rho C by BA.
Rho C by BA. That is absolutely correct. This would be the resistance of the conductor. So what we have seen is the resistance of this conductor. Even though it is the same conductor, same material, same metal, same dimension, but depending on how we have connected this conductor, the resistance can still vary. I'll give you 2 minutes to draw this last case, and then I will give you a question that you can do. So now let's move on and solve a question based on what we have learned. This is a question from one of the previous exams, and it is highly probable that you may get a similar question in your exam. Dimensions of a block are 1 centimeter into 1 centimeter into 100 centimeter. The specific resistance, when they say specific resistance, what do they mean? They mean the value of rho. Do we understand this? Specific resistance. Do we understand this? Specific resistance is rho.
Yes, sir.
The rho of that material is given as this much, 3 into 10 raised to the power minus 7 ohm meter. In the next class, we will also see some points on this rho. Don't worry. We'll also see its dimension. We'll also see its unit. What is the resistance between the opposite rectangular faces? Remember, it has 3 faces. It has 6 faces. 2 of them would be square, and the rest of them would be rectangular. So between the rectangular faces, any 2 rectangular faces, 2 faces square and 4 faces are rectangle. Do we understand this?
Yes,
Yes.
sir.
So between any 2 rectangular faces, you have to tell me, just like this one. Here all are rectangle. No, here also one is square and the other are rectangles. So you have to find out the resistance between rectangular faces. To help you out, you want me to give you a hint, or you can do it on your own? Do you want a hint, or you can do it on your own? I will give you a hint as well so that you can do this question on your own. And the hint is like this. If you have to draw the diagram, this is how it would look like. 1 centimeter, 1 centimeter, and 100 centimeter. I have drawn the cuboid for you. Can you tell me what is the answer? You have to find out between rectangular faces. So you can find out the area of any rectangular face. I am highlighting that rectangular face for you. How much is the area of this rectangular face? If I want to find out this area, how much will be the area? How much would be the area? How much would be the area? How much would be the area? Okay, no one knows it, so it will be 100. This is one of the dimension, and this is the other dimension, 100 multiplied by 1. So it will be 100 centimeter square. You can convert this 100 centimeter square into meter square. It will be 10 raised to the power of minus 2 meter square. That would be the area. If you talk about the length, this would be the length of the conductor, and the length of the conductor is 1 centimeter. So you can find the resistance of this wire rho L by A. Rho is given as 3 into 10 raised to the power minus 7 into 10 raised to the power of minus 2, which is the area.
Sir, once go back, sir.
So 3 into 10 raised to the power minus 7, that is the value of rho, multiplied by the area. Area is 10 raised to the power minus 2 divided by the multiplied by the length, which is 10 raised to the power minus 2 divided by the area, which is also 10 raised to the power minus 2, and you will get your final answer 3 into 10 raised to the power minus 7 ohms. You just have to see which option it matches, and it matches option B. So option B is the correct answer. Do we understand this, everyone?
Yes, sir.
Well, with this, we come to an end of this class. In this class, we have covered resistance. In the next class, we'll go on to see what is resistivity and also see some more questions where wire is going to get stretched and so on. These are the type of questions that are going to come. So we are putting our emphasis on these types of questions. I'll see you in the next class, that is tomorrow. Everyone has understood what we have done in today's class?
Yes, sir.
So I'll see you in the next class tomorrow. Take care and God bless all of
Thank
you.
you, sir.
Bye
Bye,
bye.
sir. Take care, sir.